Hi, welcome to Physical Science 1.4 Gas Laws. Today we're going to be talking about how pressure, temperature, and volume are related as far as gases are concerned. First law is Boyle's law. Write this in your notes. Boyle's law shows the relationship between pressure, how tight a gas is packed, and volume, how much space it takes up. I found for Boyle's law demonstrations, since I'm not really able to do a whole lot of them in class because I don't have the equipment.
In a demonstration of Boyle's law, we'll place a balloon in a vacuum bell jar. We'll apply a vacuum which basically pumps out the air in the bell jar. The pressure outside the balloon will be greater than the pressure inside. The balloon expands to try and equalize the pressure. Volume and pressure are inversely related to each other. When we release the vacuum, the pressure increases and the volume decreases. As another demonstration of Boyle's law, we will put a marshmallow peep into our vacuum jar. The marshmallow contains air trapped in a mixture of gelatin and sugar. As we apply the vacuum, the pressure outside is lower than the pressure inside. The air in the peep will expand to try and equalize the pressure. When we release the vacuum, the pressure increases and the volume decreases.
It is an inverse or indirect relationship because as the pressure increases, the volume decreases. On your formula sheet, write Boyle's law inverse. The equation is P1V1 equals P2V2. It's kind of like the momentum equation where you have the pressure times the volume before is equal to the pressure times the volume after. Pressure is measured in actually three things. kPa is kilopascals, and ATM, and sometimes you'll see an mmHg. That's a millimeter of mercury. But for the most part, we're going to look at kPa and ATM. V is volume measured in centimeters cubed and liters. In order to solve this problem, you're going to be given 3 out of the 4 variables. And you will have 2 that are side by side together and 1 on the other side of the equal sign. You will multiply together and divide. This little fill in the blank could be very helpful as you do these problems. Just kind of give yourself a before and after kind of picture to fill in. Boyle's law example. Hydrogen is stored at 1.3 atm in a 3-liter container. If it were to be released into a 50-liter container, what would the pressure be? First of all, let's start with our equation. P1V1 equals P2V2. The pressure that you're given, the first pressure is 1.3 atm. The first volume given is 3 liters. You do have to be careful about the order that things go in. They have to go in the same order that not necessarily they're given, but the same order that they go together. So this is in this container or at this volume or at this pressure. So be really careful about the order you're given things. If it were to be released into that 50-liter container, we wouldn't know that second pressure. We would then multiply together 1.3 times 3 and divide by 50 to get 0.078 atm. The second law that you're going to look at is Charles' law. Charles' law shows the relationship between volume and temperature. This is a direct proportional relationship. As the volume increases, the temperature increases, and vice versa. This is another video animation that I found on Charles' law. Okay, so the can was heated up and then picked up and put upside down into the cold water, and it smashes the can because as the temperature decreases rapidly, the volume will decrease rapidly. As the volume increases, the temperature increases, and vice versa. Add this to your formula sheet. Charles' law is a direct relationship, and the equation is V1 over T1 equals V2 over T2. Again, you have a before is equal to after situation. Whatever gas you're looking at, the volume and the temperature before have to equal the volume and the temperature after. Volume over temperature. Volume is always on top. Volume is measured in two things, liters and centimeters cubed. Temperature, however, has to be measured in K or Kelvin. And sometimes you're actually going to be given a Celsius temperature. In order to convert to Kelvin, all you do is add 273. To solve, you're going to multiply diagonal and divide because this is an actual proportion. You're going to have two numbers diagonal from each other, multiply those two numbers, divide by the third number no matter where it is, and that will give you the fourth variable that you're missing, the answer. This little template could be very helpful to set up as you read the problems. So, Charles' law example. Balloons at 300 Kelvin have a volume of 2.5 liters. If the temperature is increased to 500 Kelvin, what volume would they occupy? Again, the equation that we want is V1 over T1 equals V2 over T2. You're given two things that go together, but be very careful of where you put them. 300 Kelvin has a volume of 2.5, so those go together on your before side. If the temperature is increased to 500 Kelvin, again, that's got to go on the bottom because temperature goes on the bottom. Then we would multiply diagonal 2.5 times 500 divided by 300 and get a volume of 4.17 liters. You're going to be doing several problems today in class. Thanks for watching.